2, 3, go.
How we doing, campers? Today we're going to talk about light bulbs, and more importantly, how does a light bulb work? Now, before we can take a look at how the light bulb works, though, we're going to need to talk a little bit about electricity and how a battery or a power source is going to power that light bulb. So we've got our standard incandescent light bulb, which we'll talk about incandescence here in a few moments. We're going to need a power supply, so we've got our battery, and with our power supplies or our batteries, we know that we have a positive end and we have a negative end. So on these 9-volt batteries, the smaller terminal is going to be our negative, and the larger terminal is going to be our positive. Okay, and the way this works is there's going to be a chemical reaction that's taking place inside this battery that is creating a buildup of negative charge on one side of the battery, the negative end, and a more positive area on the other side of the battery, the positive end. So what we get is a difference in charge from one side of the battery to the other. And what we've learned earlier about charge is that, for one, do opposites repel or do they attract? Right, opposites are going to attract. And so our negative electrons would like to get over to where the positive side is. Also, this buildup of negative electrons on this side of the battery, it's going to get very crowded over there, and those guys want to move. So we're going to have the negatives want to get over here where the party's at. They want to move from the negative side to the positive side. And so right now they're not able to do so. But if we were to connect these two terminals with, say, a wire, some type of pathway that they could go from one side to the other, then what we're going to see is that the electrons would then freely flow from the negative side of the battery to the positive side of the battery. Now, with electricity, we use this in our advantage by placing something in that electricity's path. So we have a flow of electrons from one side to the other, and if instead I place something here for it to travel through on its way to the positive side, the flow of those electrons are what is going to power that device, whether it be your cell phone, your light bulbs, your radio, and we're going to take a look at how the light bulb makes that happen. So if I create a path by taking a wire and attaching it to the light bulb, okay, that charge is then going to, the electrons are going to flow through this wire, through this green wire, through across this wire, and back down the other side, again looking for this positive side. And so we've essentially created a path, a continuous path, to allow electrons to flow to the positive side, but in doing so, we're using those electrons to light up our light bulb. All right, now, if this particular light bulb, an incandescent bulb, works off of incandescence, and that was discovered back in 1807 by this guy, Sir Humphrey Davy. He was an English chemist, and what he did was he took a portion of platinum wire right here and ran a current through it. A current refers to a flow of electrons, and so the electrons flew through the platinum wire. It glowed very hot. That's our incandescence. But eventually the wire melted. Now, let's look at how that worked. To see how that works, well, I've got a wire simulated here. And through this wire, we're passing a current. So a current is essentially just the flow of charge, in this case, the flow of negative charge, electrons. So current we will call the flow of electrons.